Support for Central Florida Public Media comes from the UCF College of Business, offering the new online space MBA. Designed for professionals in innovative and high-growth industries, beginning spring 2026, students gain advanced business skills through the lens of the space economy. Learn more at business.ucf.edu/space MBA.
Federal funding and the future of space science missions. You're listening to Are We There Yet? The radio show exploring space exploration. Hi, I'm Brendan Byrne. The Juno spacecraft launched in 2011 to explore Jupiter and its moons. It arrived 5 years later, and since then has been capturing stunning images and groundbreaking data about the planet and its satellites. Its mission was extended until the end of last month. But with the government shut down, it's unclear whether Juno will continue. We'll speak with science journalist Emily Speck about the history and future of Juno. Then, one mission was spared from federal funding cuts. For now, OSIRIS-APEX. The Trump administration's proposed budget for NASA would have cut the mission, but it has since received a lifeline. We'll speak with Arizona State's Daniela Della Justina, the mission's principal investigator, about OSIRIS-APEX and the asteroid whizzing past Earth it hopes to observe. That's ahead on Are We There Yet? Launched over a decade ago, the Juno spacecraft embarked on its mission to explore Jupiter and its moons near the edge of our solar system. It's been orbiting Jupiter since 2016, originally planned as a 20-month mission. But the mission has been extended a few times. Its last extension ended last month on September 30th, right before the government shutdown. Now, its future is unclear. Here to talk more about Juno and its history studying Jupiter is Emily Speck, a science journalist covering space, science, and climate. Emily, welcome back to Are We There Yet?
Thank you so much for having me. It's good to be here.
There's quite a bit of uncertainty when it comes to NASA science missions. For one, the proposed budget, and two, the government shutdown. And one of those missions that's pretty uncertain that you wrote about is Juno. Can you tell us what we know about this mission in the here and now?
There's a lot of uncertainty, like you said, about Juno because we're in a government shutdown. As of October 1st, we stopped getting updates from NASA on pretty much anything non-essential. That includes Juno, which has been orbiting Jupiter since 2016. And it completed its first round of mission of orbits, and then it got extended, and that extension ended on September 30th. The shutdown happened the next day, so we haven't had an update whether this mission somehow got a lifeline or not, but right now we're thinking most likely not. The most recent statement I got from NASA said that they were going to adhere by that September 30th cutoff.
What does it mean for the future of this mission?
People a lot smarter than me who know more about the technicalities of orbiting Jupiter. Obviously, it's kind of an amazing engineering feat. If the mission is over, it's not going to immediately dive into the planet and be, kaput. Like Cassini, you think of Cassini with Saturn. It did this dramatic dive into the planet and RIP. With Juno, it's been out in space long enough that it kind of meets the requirements from NASA that it's not going to bring anything down to Jupiter that might bring stuff from Earth, any yucky stuff from space, whatever. So it's essentially going to orbit the planet until it gets pulled in by its atmosphere, and then it would degrade and be no more. So that's what happens if the mission is no longer operating. If it got a lifeline, that would be very exciting, but we don't exactly know.
Let's talk about Juno's history. Launched in 2011, but it took some time to get to the Jovian system. Tell us a bit about the spacecraft and what it did when it got there.
This is a really cool spacecraft. Jupiter, its radiation is kind of one of the most toxic things for anything orbiting it. We've never really had like a dedicated mission like this built and designed to last that radiation. And with Juno, it essentially had to have all of its science instruments encased in titanium to withstand that radiation. And then on top of it, it's basically our furthest deep space planetary explorer, and it had to have these massive 30-foot solar panels to kind of power it so far from the sun. In itself, it's a really cool looking spacecraft. It also had an instrument, a camera called Juno Cam, which is my favorite because it's the first time that NASA essentially took a dedicated camera and let citizen scientists look at the imagery from it and kind of help determine what they should look at. And if you've seen imagery from Juno and from Juno Cam over the years, it's most likely that you've seen some images that were processed by citizen scientists. They look like masterful art pieces. So Juno Cam is for sure my favorite instrument just because of the big win for citizen scientists on this. I love, last year I wrote a piece with a marine biologist who was doing a study on comparing the atmospheric conditions that she was seeing on Jupiter to the things, the plankton and things like that we see in the ocean on Earth. So there's a lot of comparison with the wild weather that happens on Jupiter Jupiter that you could look at Earth and see a lot of similarities. And when you look at JunoCam images, like side by side, it literally looks like some stuff that we could see swirling around in the oceans.
It wasn't just Jupiter that it captured images of, right? I'm looking at your story that you posted recently and got a picture from a citizen scientist processing of Europa and Io, and my goodness, they look almost not real. It looks like something in a video game, right?
I mean, these images are beautiful, and it's the first time we've had this detailed quality of some of these moons. It even aided in discovering another Jupiter moon. I mean, Jupiter has a lot of moons. The Jovian system is huge. I think it's like up to 80 now with moons. It's pretty crazy, but it has some really interesting ones, including Io. We just had, that flyby not that long ago, and there was a new volcano discovered. The imagery that we got from JunoCam on the volcanoes was very, very cool. And then Europa, we have another NASA mission on the way to Europa right now. And Juno really helped make sure that that mission is going to be a success studying Europa, which is pretty exciting.
Tell me a bit about Juno's orbit. It's kind of a strange one around Jupiter, isn't it?
Yeah, it's kind of like an elliptical orbit. They actually had to change the game plan pretty early on with the orbits. They were supposed to be a little closer. I think it got a few close orbits, ended on around 76 or 77 orbits of Juno, which doesn't seem like a lot for 9 years, but it's making this huge, wide elliptical orbit. So it's not going super, super tight in around Jupiter. It has to do that to avoid the radiation. But the way that they've designed these orbits, it made perfect for flybys of some of those moons like Io and Europa and things like that. 77 orbits is a pretty big feat when some of these orbits take like 40 something days.
Yeah, it's going pretty far out away from Jupiter.
Absolutely.
Back in,
Yeah.
Which is pretty wild.
Mm-hmm.
What about some science on the mission? What have been some of the scientific findings? I mean, the images are cool, but that's not the only reason it was sent out there, right?
One of my favorite things about Jupiter, it's, I'm a little biased. It's my favorite planet. It has really cool weather. And this mission kind of helped fuel a lot of the weather science. Like you think of a hurricane on Earth. Well, that's essentially a vortice. And that's what Jupiter is covered with. So, you're looking at the Great Red Spot. There were quite a few studies on the Great Red Spot with Juno data because it's essentially a giant swirling multiple hurricanes on this planet, which is awesome. There's also some very cool atmospheric conditions happening there. Juno, it brought in new data of the weather systems on Jupiter that I think for years to come, we'll be learning a lot more about that.
What do you think the legacy of Juno will be?
It's our furthest planetary explorer from the sun. So there's that. It taught planetary scientists or, principal investigators some of the things that they need to look for studying in such a harsh radiation environment. One of the things that I think is really cool that they overcame is that eventually the radiation from Jupiter did impact the instruments in JunoCam. And a couple years back, the team basically had to sit down and say, well, what can we do to essentially get our camera back and possibly extend through the second part of this mission? And it did work, but they basically created like a MacGyver move to send it way out, heat up the instruments, and then slowly cooled them down. And that kind of helped reverse some of the radiation issues that they were having. And it worked. It took a little while, but it actually worked, and they got some crystal clear images again, and then the radiation started coming back. One of the legacies of this mission will be troubleshooting a spacecraft dealing with radiation problems this far away from the sun, this far away from Earth. That's no small feat. And then building a spacecraft to withstand that kind of radiation.
And Jupiter is quite far from the sun, right? It's 481 million miles or 5 astronomical units, which is the distance between us and the sun. And I'm always shocked to hear that they use solar panels for that, right? Usually deep space missions use plutonium or uranium or something like that, right?
Yeah, and this did not. When you think of those kind of further missions, obviously New Horizons to Pluto, that went further. It's still going. It's in the Kuiper Belt, but it's kind of unique how they engineered this spacecraft to work this far from the sun. I mentioned the solar panels. They had 3 of them. It kind of spins around and it looks almost like a little spin top with the 30-foot panels. They're huge. They're absolutely huge when you see people standing next to them. That's kind of the only way that they were able to do that and operate this far from the sun.
You're listening to Are We There Yet? Here on Central Florida Public Media. I'm Brendan Byrne. We're speaking with Emily Speck. She's a science journalist covering space, science, and climate. I'm going to get personal here. Why is Jupiter your favorite planet?
It's beautiful. It's mysterious because we don't exactly know what's going on beneath the surface. I mean, we have a lot of good ideas. It's not like our rocky worlds that we're like, okay, we've got Martian explorers, we've got robots on Mars, we can actually knock on that planet with a spacecraft or with a drill. It's not like that. And it's just incredibly mysterious in that we're not entirely sure, how it got its start. Then again, the weather. I mean, it's just such a cool weather. Once I learned that basically the planet is covered in hurricanes, that's just like, and they have like conflicting streams. On Earth, we have different atmospheric streams that influence things. Jupiter has them all over the place. It's a nuts planet. It's just mysterious and it's so beautiful.
Thinking of more than one hurricane on a planet is absolutely terrifying to a Florida-based journalist. So thank you for putting that into my head, Emily.
For sure. Hopefully not in our lifetime.
Yes. Another kind of scientific mystery that scientists have been following is 3i Atlas. What the heck is this thing, and why has it been getting so much news coverage these days?
Yeah. So this space object, it's an interstellar object. So this is the third time that astronomers and the scientific community as a whole have found an object from outside our solar system and tracked it through our solar system. We've only had two others. The other one most recently was in 2019. And it's very exciting because we don't get a lot of these visitors. We probably have them more than we know. But so it disappeared kind of behind the sun from ground-based observatories. So now scientists are using spacecraft already out there, like James Webb Space Telescope, Hubble Space Telescope. And if Juno was functional, Juno could have been watching out for this object because essentially it's going to make its closest pass to the sun. It went by Mars a little while ago, and then it's going to head out past Jupiter. It won't be as close as it got to Mars, but it would have been really cool to see if JunoCam could have picked it up possibly, or any other instruments. Thankfully, we've got the European Space Agency. They've got some other spacecrafts that are watching it. And we do know that when it flew by Mars, hopefully our NASA Mars spacecrafts and the rovers were looking out for it. But it's a really cool object. So far, it's our largest interstellar visitor. So that's one thing. It also has an interesting chemical makeup. There's some people who are saying, well, what could possibly explain this chemical makeup? Is it aliens? And as we know, it is probably not aliens, but it's still really exciting when an object has more questions than answers. So I've enjoyed following it.
Yes, very intriguing. Well, finally, Emily, the future of NASA science is uncertain. We know that, but is there anything in particular you're looking forward to outside of the Juno spacecraft?
Yeah, absolutely. The Europa mission that launched last year. We've had some really good images from Europa from the Juno mission, but the thing that's exciting about Europa is that, they believe that it has a global ocean. There have been quite a few studies about, we hear this every once in a while, that there's the ingredients for life, possibly within this ocean, which doesn't mean they're going to find aliens. It just means they might find possibly microbial life or the ingredients. It's very exciting because when we think of life on Earth, we think of water. So to see a world, a moon that is potentially with this undersea ocean, it's exciting. So I'm hoping to see that goes well. On another note, it's unfortunate that we're looking at a lot of missions that are going to be potentially cut, under the proposed budget. Juno was one of those missions. So that's another reason why it's very unlikely we're going to get good news after the shutdown. There are a lot of other exciting missions coming up.
Juno paving the way for Europa Clipper to possibly find signs of life in our solar system. We've been speaking with Emily Speck. She's a science journalist covering space, science, and climate. Emily, thanks for coming to the show.
Appreciate you having me.
Still to come, studying an asteroid that'll zoom by Earth in the next decade and how it was saved from federal funding cuts.
We aren't going to get, a tidal counter between an asteroid and the Earth a few years after that, right? This is truly a once in every 7,500-year opportunity.
That's ahead on Are We There Yet? You're listening to Are We There Yet?, the radio show exploring space exploration from Central Florida Public Media. I'm Brendan Byrne. From classic space and science fiction movies like Alien and Star Trek to more horror dystopian movies like Planet of the Apes, there are a lot of spooky space-themed movies to watch this Halloween. So what to watch this spooky season? NPR's media critic Eric Deggans joins us with his top 10 favorite space and sci-fi horror films. That's next week on Are We There Yet? But for now, we're talking about OSIRIS-APEX. OSIRIS-APEX is a mission that spawned from OSIRIS-REx, the mission to the asteroid Bennu that returned a sample of dirt from its surface. Scientists are looking for life-building compounds and answers to how life may have began in our solar system. The next chapter of that mission, APEX, will study another asteroid named Apophis that will be flying close to Earth in 2029. The mission hopes to learn about how Earth's tidal forces will affect the asteroid, providing insight into how we might defend our planet against a similar one, and one that threatens to smash into Earth. But when the Trump administration proposed cutting 25% of NASA funding, the OSIRIS-APEX mission almost ended. The mission, however, received a lifeline. Here to talk more about the mission and its future is the principal investigator of NASA's OSIRIS-APEX mission, Arizona State's Daniela Della Justina. Daniela, welcome to Are We There Yet?
Thanks.
Tell us what this part of the mission is all about.
So in 2023, when the OSIRIS-REx mission dropped off the sample of asteroid Bennu that it had collected, the spacecraft was still in great shape. And it didn't really have a purpose. We had never planned for an extended mission when OSIRIS-REx was being developed. So about a year prior to sample return, we began doing just that, trying to figure out, okay, what can we do with this really phenomenal spacecraft after the samples come back to Earth? And we identified that the spacecraft could rendezvous with another small asteroid called Apophis in the year 2029, just after Apophis makes a really historic close approach to the Earth. Apophis is one of these more infamous near-Earth asteroids that's been discovered because, as I mentioned, in 2029, it gets very close to the Earth. It, in fact, gets within a tenth of the distance between the Earth and the Moon. When it gets that close to our planet, there is going to be a tidal force that's exerted by the Earth onto the asteroid. So we don't know precisely how that is going to affect Apophis. Earth's gravity is going to tug on it. It's likely going to change its rotation rate. So the length of a day on Apophis is likely going to change. We know for certain its orbit is going to change because Earth is going to impart extra energy on the asteroid and slingshot it a little bit while it's in the gravitational influence of our planet. There's a whole range of what if scenarios. So what if there are landslides as Earth tidally tugs on this asteroid? What if there are particles that get ejected from the surface? Those are the things we don't know, and that's precisely why it's so exciting to send a spacecraft there to study it.
It seems now with this close flyby, you are going to be observing things that happen to the asteroid itself.
Yeah, that's one way to think about it. So, one thing that's very interesting about this close encounter between Apophis and Earth in 2029 is we've never observed anything like this before. These events where an asteroid that's relatively large, Apophis is as wide in its longest dimension as the Empire State Building is tall, so around 500 meters or so, they only get this close to our planet about once every 7,500 years. So this will be the first time in recorded history that we know of an object getting so close to Earth. And it's interesting from a planetary defense perspective to figure out, okay, what might start happening to an object like Apophis when it gets this close to our planet? And can that give us any idea about, how strong it is, how cohesive is the body? And those are really important questions that we need answers to eventually defend the Earth against a hazardous asteroid that is making it all the way to the surface through an impact. And so it is funny to think about, well, in this case, Earth is picking on Apophis and not vice versa. But by studying the event, we really are going to learn a little bit about sort of these planetary defense concepts.
So by what you learn from this close pass-by of Earth and how its trajectory may change or what happens to the surface of the asteroid, Can you then extrapolate it and think about how other planetary bodies that an asteroid may be passing by could impact its trajectory and then also help plan if it's going to hit us or not?
We have this sense that close tidal encounters between asteroids or comets and larger planetary objects have shaped solar system dynamics over time. But we have very few actual observations of this happening. So one of the few observations in our record is Comet Shoemaker-Levy 9, which, if you remember, it impacted Jupiter in the 1990s. This was, I think, the first opportunity we had to witness an event like this, and we saw the comet sort of get tidally torn apart, right, as it got closer to Jupiter, which has a much stronger gravitational field than our own planet, and then subsequently impacted the surface. So this gives us basically a second data point to see how tides from these larger planets really are affecting and shaping these small bodies. There is a debate in the scientific community. A lot of people think that the tidal's exertion onto Apophis, it's not going to reshape the asteroid. It's not going to cause landslides. But over the past 20 years or so, as we've sent more and more spacecraft missions to these small bodies, we're learning that they are rubble piles. They're very weak. They have almost no internal strength. They're sort of just like a loosely bound collection of rocks and boulders and dust. And so this opportunity is going to give us a little bit of insight. Seeing how Apophis responds to Earth is going to give us a little bit of insight into exactly how strong it is. We may have some surprises on our hands. And I think, that's why we do this. That's why we do science. We often go into a big mission having a strong expectation of how things are going to turn out, only to be proven wrong. And that was exactly the case with OSIRIS-REx, right? We did a tremendous amount of work before we ever got to Bennu to show that this asteroid should have plenty of loose, fine material on its surface in order for us to sample it. And we designed a sampling mechanism that was only allowed us to ingest really small particles on the asteroid. And when we got there, we had a really hard time finding that fine grain material because the asteroid was just littered with boulders. And so every time we go in to what I would consider a grand experiment, which is what the 2029 Apophis Earth encounter presents us with, we open ourselves up to have our hypotheses, refuted. And that's kind of the most exciting part.
Do we need to be worried about this?
Absolutely not. Apophis will not impact the
Good
Earth
news.
in the year 2029. And we know that no asteroid is going to impact the Earth for at least the next 100 years.
You're listening to Are We There Yet? I'm Brendan Byrne. We're speaking with Arizona State's Daniela Della Justina, the mission's principal investigator, about OSIRIS-APEX. How are you actually going to be making these observations?
Right now, the OSIRIS-APEX spacecraft is orbiting around the sun. We are basically waiting until Apophis makes its close encounter with the Earth to then catch up to it. One of the unique things that I mentioned earlier about Apophis is its orbit will change as a result of that close approach that it makes in the year 2029. And we're going to take advantage of an Earth gravity assist right before we ourselves rendezvous with Apophis in order to match its new orbit. It's kind of a waiting game. We are circling the sun. Our heliocentric orbit, or our orbit around the sun, is taking us a little closer to the sun than the spacecraft was designed to get. Luckily, so far, we've survived that more intense thermal environment than we were built to survive. So it's great. We have fantastic spacecraft engineers that have made that work. And we'll take some observations of our own planet as we're hanging out in the inner solar system. But it all comes down to the last few months of our cruise phase, where we need to have a slingshot from our own planet in order to match Apophis's new orbit.
Where does this mission stand in the here and now?
We were proposed for cancellation in the spring of this year. And luckily, we spent a lot of time talking to our counterparts in the House and the Senate. The mission is based at the University of Arizona. And so we have a really strong support within the Arizona congressional delegation. And it's bipartisan support because our stakeholders in Congress really understand the importance from a planetary defense perspective of this mission, as well as the rarity of this event. So if we don't send a mission to Apophis in 2029 to study this tidal encounter, we aren't going to get, a tidal counter between an asteroid and the Earth a few years after that, right? This is truly a once in every 7,500 year opportunity. And because we were able to communicate that support, and that support was communicated more broadly, we saw ourselves in both the House and Senate versions of NASA's budget as outlined in various appropriations bills. And so NASA used that guidance to inform how they were going to plan for the next fiscal year. So we received word just a little bit before October 1st that we have full funding and support through FY26. Now, we are in a government shutdown, but luckily, these missions are planned in a really thoughtful way where you have a certain amount of what we call as funding carryover. So we have a certain number of dollars from last fiscal year that's intended to get us through the fiscal year boundary. So we are in great shape. We just ourselves did an Earth gravity assist at the very end of September. A few days later, on the other side of the fiscal year boundary, on October 4th, we cleaned up the spacecraft's trajectory following that Earth gravity assist. We're continuing to cruise.
Is OSIRIS-APEX up to anything else while it's kind of waiting for the main event?
First of all of our cameras and spectrometers, everything basically with a lens on it, got pretty dirty when we sampled Bennu. We are characterizing what the signature of Bennu's dust on all our instruments looks like and how we can remove it so that we get the best possible data of asteroid Apophis. And so the recent Earth gravity assist that we did gave us an opportunity to take pictures of the moon. The moon is a really well characterized object. And so we're looking at how the light is observed by all of our instruments of the moon and then comparing that to sort of known standards and using that to recalibrate our instruments. So that's some important work.
That's so cool.
Yeah, but we have been observing our own Earth as though it's an astronomical object across all of our different instruments. And the reason for this is we have some pretty unique instruments on board the spacecraft that are not too different from some of the instruments that NASA would like to use in the future to study exoplanets. Earth is the one example of a planet in the universe where we know there is life, and we know there is signatures of life and habitability that should be observable on our own planet. And so by studying Earth when it's pretty far from our spacecraft and it's occupying just a tiny fraction of the field of view in our instruments, we can see, are those indications of life and habitability, are they even observable? And I'm going to be really excited to talk to you about that maybe in a year or two from now when we can present on those results.
That was the principal investigator of NASA's OSIRIS-APEX mission, Arizona State's Daniela Della Justina. That's going to do it for this week's show. If you're not already, be sure to subscribe to the show's podcast feed so you never miss an episode. Subscribe on Apple Podcasts, Spotify, or wherever you get your podcasts. Stay connected with this show. Be sure to follow us on social media. Our handles on Instagram and Facebook are @AWTYSpace. And if you've got an idea for a future episode of the show, or you want to join us as a guest, reach out. Our email is areWeThereYet@cfpublic.org. Are We There Yet is a production of Central Florida Public Media. Our intern is Orion Boone. Our producer is Marian Summerall. Editorial guidance from LaToya Dennis. Support for Are We There Yet comes from our listeners. Until next week, I'm Brendan Byrne. Thanks for listening.